Hey everyone, welcome to a deep dive into something kind of hidden but super important, microchip design.
Yeah, it's wild. These tiny things are everywhere.
Right. And today we're going deep on chip placement.
Mm.
How engineers decide where each of the millions, billions of parts go on these chips.
It's like imagine a puzzle, but instead of cardboard, it's microscopic transistors and wires needing to be perfect.
Whoa, okay, that's a serious brain teaser. Which is why we're diving into this Google AI research,
Oh, yeah.
chip placement with deep reinforcement learning. Even the title's intense, but the stuff inside, this is going to be good.
Definitely. Shows how AI is being used not just in tech, but to build better tech. The
Yeah.
future is now, kind of thing.
AI building tools for more AI, wild. But for those of us who aren't, chip wizards, what makes placement so hard?
Okay, so every tiny decision impacts the whole chip. Power, speed, heat, all in a space smaller than a fingernail.
And this was all done by humans, right?
Yeah, experts spending weeks, months even, arranging these components. But chips are getting so complex, we're hitting a wall. That's where AI comes in.
And that's where the Google paper comes in. Deep reinforcement learning for this. Sounds like sci-fi.
Right. Like teaching a computer to play a game, but not every move. You set the rules, it learns by trying.
So AI playing Tetris, but with billions of microscopic pieces, stakes are a little higher.
Kinda. The game is arranging the chip. The reward is if it's crazy efficient, low power, super fast, and actually fits on the chip.
And it gets better each time.
Exactly. It learns, gets better until it's cranking out these awesome designs. But here's the cool part. Domain adaptation.
Wait, does that mean what I think? It can design any kind of chip.
Yep. Learns to design a phone chip, then boom, a power-efficient one for a hearing aid. It adapts, becomes this universal chip architect.
This isn't just automation, it's problem solving across fields. That's huge for the future of tech.
Huge. But let's get into the details, how they actually did it. Billions of components, right? They had to get creative.
Oh, absolutely. Lay it on me.
So, like, picture a billion-piece puzzle,
Right, yeah. Where do you even start?
Exactly. They had to simplify it somehow. So first, they grouped all those tiny parts into, like, clusters. Instead of looking at each piece, it's chunks now.
So it's working with bigger pieces. Makes sense.
And, get this, they made a grid system, like a simplified map of the chip. Helps the AI see where things go.
Okay, starting to get it. But even then, isn't there still a crazy number of ways to arrange everything?
Oh, tons. But here's where it gets cool. They use this force-directed method.
Force-directed, like magnets, you push them together and they...
Kind of, like simulating physics, but on the chip. Components with strong connections, they're pulled closer. Weak connections, they drift apart.
Finding the path of least resistance, but for electricity on a chip.
Exactly. Less resistance, faster it goes, and less power used.
Right. Shorter distances, faster speeds. What about the big pieces, though? Don't those mess things up?
Good point. They actually had the AI place the biggest components first.
Ah, like starting a jigsaw puzzle with the edges makes a framework.
Exactly. And speaking of puzzles, you know what else was interesting in the paper? Donuts.
Donuts. Wait, the AI made donuts?
Well, donut-shaped arrangements of components. Sounds weird, but it worked.
Okay, I'm confused now. Explain it like I'm 5, but I also build computers.
Haha, right. So data flows through the chip, yeah. These donut shapes, they're like shortcuts. Data doesn't have to travel as far.
So it gets where it's going faster.
And uses less power. The crazy thing is, human engineers hadn't even thought of this donut thing.
So the AI found something totally new that works better. That's kind of scary, but also awesome. But be honest, how do these AI chips compare to human-made ones?
$1 million question. And the answer is complicated.
So we've got AI making donut-shaped chips, stuff humans haven't thought of. Are we, like, out of a job now?
Everyone's wondering that, right? But what if it's not us vs them, but working together?
Okay, so more like AI is our design buddy.
The research found AI is amazing at exploring tons of ideas, but it still needs that human touch.
So it's like AI gives you the rough draft super fast, and then the human expert comes in to fine-tune it, make sure it actually works in the real world.
Exactly. We're good at the nuance, the big picture stuff. AI takes care of the tedious parts.
I like that.
Yeah.
But even then, the speed is crazy, right? Designs that took weeks, now it's hours.
Huge difference. Faster development means new tech gets to people quicker. New phones, medical devices, stuff we haven't even thought of yet.
Okay, now that's kind of scary and exciting.
Yeah.
But it makes you wonder, if AI can do this, what else can it do?
Right. Researchers are asking that about everything. New medicines, better solar panels, maybe even figuring out how the brain works. It's crazy.
Like we're on the edge of something huge, and AI is opening those doors.
And while we have to be careful, ethics and all that, it's hard not to be a little amazed by what's coming next.
Amazed, not terrified. I like that a lot more than the robot overlords thing. But that's probably a good place to leave it for today.
Definitely been a fun ride through chips, AI, and the future of, well, everything.
Thanks to everyone listening for joining us as always. Keep those brains buzzing. We'll be back soon with more deep dives. It's kind of wild how much we rely on AI these days, right?
Yeah,
Self-driving cars, those recommendations online that are scary accurate.
it's everywhere.
Yeah, it really is. But get this. What if we told you that AI is now designing the very chips that power all that AI?
Meta.
Totally.
Right.
And that's exactly what we're diving into today. We found this research paper, and it's all about a major breakthrough in using AI, specifically for something called chip placement.
Okay, chip placement.
Yeah, before we kind of get ahead of ourselves, let's break down why this is such a big deal, because I think a lot of people listening, they hear chip placement, and they're like, okay, what does that even mean?
Right.
So we're talking about the microscopic level of computer chips, billions, with a B, of tiny transistors and components, all needing to be arranged perfectly on a space smaller than your fingernail.
It's mind-boggling when you actually try to picture it.
Oh, absolutely. It's insane. I was reading this paper and trying to come up with an analogy, right? Imagine you're designing a city, but it have billions of buildings, each with its own unique function and connections, and you're trying to make it as efficient and space-saving as possible.
And it's not just about fitting the pieces together, you're actually optimizing for multiple factors at once.
Hmm?
Power consumption, performance, and the physical area of the chip. Engineers call this PPA.
Right, PPA. So it's like you wouldn't want your phone to have like amazing battery life, but then it runs super slow. Or the opposite, crazy fast, but it's the size of a brick.
Exactly. It's all about finding that sweet spot where everything's working in perfect harmony.
Total balancing act.
Yeah, and that's what makes chip placement such a challenge. Because every single decision, even at that microscopic level, can impact how the entire system performs.
It's like a domino effect.
Literally. You shift one tiny component, you might save a little space, but then it affects how efficiently electricity can flow through, impacting performance, battery life, the whole thing.
It's wild. And the paper actually mentioned, this is crazy, it can take human experts weeks of like painstaking effort to create a decent chip layout. Weeks.
Yeah, it's a ton of work, very specialized.
So you can see why researchers are turning to AI for a little help.
Makes sense. But how do you even begin to teach a machine to do something that intricate and nuanced?
That is the million-dollar question. And this is where things get really interesting. The researchers in this paper, they turned to something called deep reinforcement learning to tackle this challenge.
Reinforcement learning. We've been hearing a lot about that lately.
You bet.
Yeah.
And it's actually pretty cool. It's kind of the same way we train a dog to do a trick, right? You reward the behavior you want to see.
You're basically teaching it by trial and error, rewarding good outcomes, and the AI learns to maximize those rewards.
Exactly. So you give the AI a goal, and it's got a set of actions it can take.
Yeah.
Each time it does something that gets it closer to that goal, it gets a reward. It's like over time, it learns to maximize its rewards by taking the best actions, just like a dog learns to sit for a night.
That's a great way to put it. So in the case of chip placement, the state is the partially placed chip. The action is choosing where to put the next component, and the reward is how much better the chip performs based on that decision. It's learning as it goes.
I love how that all fits together. And of course, we have the deep reinforcement learning, which is the neural network. That's the complex algorithm they're using, loosely modeled after the human brain. It's the network that lets the AI analyze all this data and learn from it.
And that's where things get really interesting. The researchers didn't just let the AI loose on a blank slate. They used a technique called domain adaptation.
Domain adaptation. Okay, break that down for me. It sounds kind of intimidating.
Imagine if, before you started learning a new language, you could download the grammatical structure and vocabulary of a similar language you already knew. You'd pick it up much faster, right?
That would be amazing. I wish I had something like that for Spanish.
Me too. That's essentially what domain adaptation does for AI. In this case, the researchers pre-trained the AI on a massive data set of existing chip designs. It's like giving it years of human expertise and knowledge before it even starts tackling the problem on its own.
So instead of starting from scratch, the AI is building on the work of countless engineers who came before it. That's fascinating.
It is. And what's remarkable is that the AI isn't simply copying these existing designs, it's learning the underlying principles and patterns that make them successful.
It's almost as if the AI is learning to think like a chip designer, but with the added advantage of being able to process information and explore possibilities far beyond human capabilities. So we have this AI, trained on the fundamentals of chip design and equipped with a powerful neural network to guide its decisions. But did it actually work? Well, drumroll please. The results are in, and spoiler alert, this AI didn't just pass the test, it aced it, like blew it out of the water.
Yeah, it's pretty massive.
Remember how we were talking about those weeks, those painstaking weeks that human experts need to design these chips? Well, this AI, it was able to achieve comparable results, sometimes even better, in a fraction of the time.
We're talking like going from weeks down to hours.
That's insane.
And it's all right there in the paper. Table 2, they lay it all out.
You know we love a good table.
Yes.
So, for all our data visualization fans out there, check out Table 2. But what's really interesting here is it's not just that the AI is faster, it's that it wasn't simply mimicking those designs it had learned from. It actually came up with brand new solutions.
Totally. Even the researchers were surprised.
It even created these, like, get this, intricate, almost artistic layouts, they describe them as. Get this, donut-shaped.
Donut-shaped chips. I mean, who would have thought?
Right. Donut-shaped chips. Never thought I'd say those words together.
But it's kind of cool, you know? It's like this AI is showing us there's more than one way to design a chip, more than one way to approach a problem.
Like expanding our horizons beyond what we even thought was possible.
Exactly. It's a perfect example of how AI can push those boundaries, you know? It's not about replacing human ingenuity. It's about amplifying it, giving us new tools and perspectives.
It's like having a superpowered brainstorming partner, one that just comes up with these wild ideas you'd never think of.
And then you can take those ideas and run with them.
So where does this leave us? What does this mean for the future? Are we all going to be living in a world run by AI-designed chips?
Maybe, but I think the bigger picture is the potential this unlocks, right? Imagine like designing custom chips for anything, medical devices, scientific research, all with this incredible speed and efficiency we've never had before.
It's like personalized chips tailored to specific needs. That's kind of a game changer.
It's about accelerating progress in every field imaginable. If AI can tackle something as complex as chip placement, who knows what else we can throw at it? What other impossible challenges can we suddenly solve?
It's both exhilarating and a little bit, I don't know, intimidating. Like we're stepping into this uncharted territory.
Yeah. Absolutely. But that's what's so exciting. It's a whole new world of possibilities.
It really is. And that's what we love about these deep dives, right? Getting to explore these cutting-edge advancements together with all of you listening and really ponder the implications.
And hopefully spark some inspiration along the way.
Exactly. So if you're as fascinated by this AI chip-making thing as we are, definitely go check out the full paper. It's called Chip Placement with Deep Reinforcement Learning. You can find it online.
It's worth a read.
And until next time, stay curious, keep exploring, and we'll catch you on our next deep dive. What if I told you there's a way to design the brain of your smartphone?
Your laptop.
Even the most powerful gaming consoles.
Significantly faster than we do now.
We're talking about computer chips.
Those tiny marvels of engineering.
And the potential for AI to design them at lightning speed.
You've sent us some really interesting research about this.
Specifically using something called deep reinforcement learning for chip placement. Let's dive in.
It's a fascinating area.
And it tackles a major bottleneck in the tech world.
You see, chip design,
especially the placement stage,
is incredibly intricate.
We're talking billions of transistors.
All needing to be meticulously positioned.
On a surface smaller than a dime.
It's like a micro-scale game of Tetris.
But with exponentially higher stakes.
And I'm guessing this meticulous placement
is what takes so much time.
Precise.
Traditionally, expert human engineers use specialized software
to figure out the optimal placement for each component.
But this process can take weeks.
Even for a team of specialists.
Weeks.
Wow.
That really puts the brakes on innovation, doesn't it?
Absolutely.
This bottleneck impacts development of everything.
From smartphones and laptops
to self-driving cars and medical devices.
And it's one of the reasons
we're feeling the limitations of Moore's law and Dennard scaling.
More acutely than ever before.
We can't simply rely on transistors getting smaller and more efficient anymore.
We need fundamentally faster ways to design the chips themselves.
Which brings us to the heart of the matter.
Can AI offer a solution?
Can we teach machines to navigate this complex world of chip design?
And break through this bottleneck?
So we're facing this massive challenge.
This bottleneck in chip design.
And the solution might just be
teaching an AI to play.
A superpowered game of Tetris.
You're closer than you think with the Tetris analogy.
Imagine instead of colored blocks.
We have these microscopic transistors.
And the goal is to arrange them.
For maximum speed and efficiency.
Deep reinforcement learning.
Is essentially training an AI agent to do just that.
An AI agent.
So not a robot with tiny tweezers.
Carefully placing each transistor.
Not quite.
Think of the AI agent as a virtual apprentice.
We give it the rules of chip design.
The toolbox of components.
And a way to evaluate its performance.
Things like how fast the chip can run.
How much power it uses.
And so on. And then we let it loose to experiment.
Exactly.
The agent starts making placements.
Initially pretty random.
And for each attempt,
she gets feedback. If a placement improves the chip's performance,
it's rewarded.
If it hurts performance,
it's penalized.
Over time, this feedback loop
helps the AI learn which placements work best.
Okay.
I'm starting to see how this connects back to my game analogy.
It's like when I play chess.
Each move I make has consequences.
Good or bad.
And the more I play,
the better I get at anticipating those consequences.
And making strategic decisions.
That's a great way to put it.
This AI agent is essentially learning to play the game of chip placement.
Constantly improving its strategy.
Based on the feedback it receives.
So this AI is essentially learning by playing millions of rounds of chip placement chess, but you alluded to something really interesting earlier.
You said it wasn't starting from scratch every time.
That's right. This is where the domain transfer concept comes in.
Domain transfer.
It sounds like something out of Star Trek.
It's not teleportation, unfortunately.
But it's just as cool in the world of AI.
Instead of starting with a blank slate, this AI agent was actually pre-trained on a massive data set of existing chip designs.
So it's like giving our chess AI access to a massive library of grandmaster games.
Before it even plays its first match.
Exactly. It's able to analyze millions of placements from successful chip designs.
Learn the underlying patterns and principles that lead to optimal performance.
And that pre-training actually makes a difference.
A huge difference. The researchers found that the AI with domain transfer consistently outperformed versions trained from scratch.
It wasn't just memorizing specific placements.
It was learning something fundamental about good chip design.
So we've got this AI trained on a mountain of data, able to learn and adapt its strategies.
But the real question is, how does it actually stack up against human experts?
That's the exciting part. This AI didn't just outperform traditional algorithms.
It went head-to-head with human chip designers and either matched or even exceeded their performance.
Wow. So in a matter of hours.
This AI is achieving what takes human experts weeks to accomplish.
Precisely. And it's not just about speed.
The AI consistently achieved impressive results across key metrics.
Shorter wire lengths, which means faster processing speeds.
Reduced congestion, leading to more efficient energy use.
Improved timing to prevent bottlenecks.
And overall, better power efficiency.
That's remarkable. This isn't just an academic exercise.
It's generating viable chip designs that could revolutionize the tech industry.
Absolutely. And that brings us to the broader implications.
This is what gets me really excited. Faster chip design.
Doesn't just mean we get the next generation of gadgets quicker.
It impacts virtually every field imaginable.
Exactly. Imagine the possibilities in medicine.
Where AI-designed chips could power sophisticated medical imaging devices.
Leading to earlier and more accurate diagnoses.
Or in scientific research.
Where faster processing speeds could accelerate drug discovery or help us tackle climate change.
The potential is truly limitless.
And it all stems from this breakthrough in AI-driven chip design.
It's incredible to think that we're on the cusp of such a transformative shift.
All thanks to an AI that's essentially a master of micro-Tetris.
And as we delve deeper into this world of AI-driven design, there's one question I think is particularly intriguing.
What's that?
Well, this AI is clearly brilliant at placement, but chip design involves numerous other complex stages.
Could AI revolutionize those aspects as well? What if we could automate the entire design process from start to finish?
That's a question worth pondering, and one that I have a feeling will lead to even more groundbreaking advancements in the years to come.
Indeed.
Well, this has been a fascinating deep dive, and it seems like we've only just scratched the surface of AI's potential in chip design.
For our listeners who want to explore further, we've included links to the research in the show notes.
Thank you for having me.
It was a pleasure, and until next time, keep those minds curious and those imaginations running wild. Imagine holding the future of faster, more powerful smartphones, laptops, even self-driving cars, all in the palm of your hand.
Mm-hmm.
That's what we're talking about when we talk about computer chips.
Yeah.
You've sent us some research about making those chips better, faster, with the help of AI.
Right.
Chip placement with deep reinforcement learning, it's called. And it's got me really curious.
And it should. This research tackles a fundamental bottleneck in chip design: chip placement. It's a bit like trying to fit a massive, intricate jigsaw puzzle together.
Okay.
But instead of just fitting shapes, each piece is connected by invisible springs, these circuits, all with different tensions, all affecting each other.
Okay, I'm starting to picture it. Millions, billions of tiny components all needing to be arranged perfectly on this tiny chip.
Yes.
Sounds like a nightmare.
It is incredibly complex.
Yeah.
Chip placement is about way more than just fitting things in. It's about optimizing everything.
Yeah.
Speed, how much power the chip uses, the area it takes up on the silicon wafer.
Right.
And you have to make sure everything can actually be wired together, which gets really tricky with billions of components.
So walk me through this research. How does it propose to solve this puzzle?
Yeah.
And what makes it so different?
The researchers have essentially created an AI agent
Okay.
that learns to place components on a chip using something called reinforcement learning.
Reinforcement learning, that rings a bell.
Think of it like training a dog. You give a treat. When they do something right, and over time, they learn to repeat the behavior that gets them the reward. Here, the AI agent gets rewarded for placements that improve the chip speed, power consumption, all those critical factors.
So it's like this AI is playing a game, constantly trying different chip layouts.
Yeah.
And getting scored on how well each one performs.
Exactly. And the cool part is, with each chip it tackles, the AI gets better and better.
Yeah.
It builds up a kind of intuition, learning from its past successes and failures.
So what you're saying is this isn't just about designing one chip really well. It's
Right.
about the AI learning how to design A and Y chip more effectively.
You got it. That's the real breakthrough here.
Okay.
The paper claims this AI isn't just faster than traditional methods. It actually designs chips that outperform those made by human experts, and even beats simulated annealing, which is a widely used optimization technique that's been the gold standard in chip design for years.
Wow, beating human experts AMD, a gold standard algorithm.
Yeah.
That's a bold claim.
It is.
So how does this AI's approach actually differ from how human engineers have been tackling chip placement?
So traditionally, chip design has relied heavily on human expertise,
Right.
painstakingly fine-tuning placements over weeks or even months. It's a very iterative manual process,
Yeah.
and it can be difficult to explore truly novel layouts.
So the AI, because it learns differently, is
Right.
able to come up with designs that humans might miss.
Yeah.
We're talking about radically different looking chips here.
That's exactly what's so fascinating. The AI's design choices are sometimes unexpected,
Okay.
yet surprisingly elegant.
Okay, now you have to give me an example.
Sure.
What's an elegant chip design?
Well, in the paper, there's this striking visual of the AI's placements
Yeah.
forming a kind of donut shape.
Wait, hold on. Donut shaped chips?
Yeah,
I've never pictured a chip looking like that.
right.
Yeah.
It's not your typical layout. What the AI figured out is that by arranging the larger components in a ring, almost like a donut's outer edge, and then placing the smaller components in the center,
Right.
it could minimize the length of the wires connecting everything.
Ah, so shorter wires, faster signals, less power consumption.
Exactly.
That makes sense. But to even think of that kind of layout, it's like this AI is thinking outside the box. Or maybe outside the silicon wafer in this case.
Precisely. It highlights the potential of AI to not just optimize existing designs, but to actually discover entirely new design principles
Right.
that could push the boundaries of what we thought was possible.
This is really making me think differently about AI. We often hear about it replacing jobs,
Yeah,
which is a valid concern.
sure.
But this almost feels like a partnership with AI pushing the limits of design
Right.
in ways humans might not have imagined.
It's a crucial point. We often frame AI as this either-or proposition, humans versus machines.
Right. Yeah.
But this research suggests a future where AI augments human capabilities, leading to a kind of collaborative creativity. That could be incredibly powerful.
So what does this all mean for the future of chip design?
Yeah,
And even beyond that, for other design-heavy fields?
that's the big question, isn't it? This research really just scratches the surface. We focused on chip placement,
Yeah.
but this type of AI-driven design could revolutionize fields far beyond microelectronics.
So we're potentially talking about AI designing everything from bridges to buildings,
Right.
maybe even fashion, like you said earlier. That's a wild thought.
Yeah,
But if it can design a better computer chip,
exactly. Imagine AI architects collaborating with human engineers or AI fashion designers working alongside human stylists to create clothes that are both beautiful and functional, even personalized to your body type.
and this all goes back to speed, doesn't it? If AI can design a complex computer chip in hours instead of weeks, what does that time saving mean for innovation across all these industries?
It's huge. It could dramatically accelerate the pace of technological advancement. New products and solutions could be developed and brought to market much faster.
Which then makes me wonder, what happens to the role of human designers in this future? Are we talking about AI replacing human jobs, or is it more nuanced than that?
It's a question that comes up a lot with AI, and rightfully so.
Yeah.
But I think it's less about replacement and more about evolution. As AI takes on more of the technical heavy lifting, the role of human designers will likely shift towards higher level thinking.
So more about guiding the AI,
Right.
setting the goals, and focusing on the creative vision,
Yeah,
rather than getting bogged down in the technical details.
exactly. We might even see the emergence of entirely new design jobs, roles that we can't even imagine yet, all centered around this collaboration between human ingenuity and AI's computational power.
That's an exciting and slightly daunting future to consider. It sounds like this research is really just the tip of the iceberg when it comes to the potential of AI in design.
Absolutely. It's a powerful reminder that we're on the cusp of a major transformation in how things are designed and made.
Well, I, for one, am both excited and a little terrified to see where it all leads. If AI can learn to design a better computer chip, who knows what other complex problems it might tackle? Maybe even help us solve some of the world's biggest challenges. But that's a deep dive for another day.
Indeed. There's always more to explore.
And explore we will. Thanks for joining us on this deep dive. Until next time, keep those questions coming. All right, so you're curious about AI designing computer chips, huh?
Mm.
We're diving into some fascinating research today. A paper with the catchy title, chip placement with deep reinforcement learning. And
Of course.
trust me, it's way more interesting than it sounds.
It really is. This paper goes right to it. Can we really automate something as intricate as chip design? And what happens then? What does that mean for tech in general?
Exactly. So we know AI is great at things like games, but chip design on a whole nother level. What makes chip placement in particular so challenging?
Imagine you're building a miniature city, right? But instead of buildings, you're placing millions, even billions of these microscopic pieces. Each one has its own little quirks, its own function,
Right.
and where it can actually go. So that's essentially chip placement. You have to figure out the optimal arrangement of these teeny components on this little piece of silicon.
Okay, I see why you'd need more than just a calculator for that.
Oh, yeah.
You need a supercomputer, why AI, to even tackle that. But this paper's not just cramming these parts together, right? There's got to be something about efficiency in there, too.
Absolutely. It's not enough to just fit them all on there. You also need to make sure that the data can flow between them smoothly and efficiently.
Right.
We're talking speed, power consumption,
Yeah.
heat dissipation,
Yeah.
all while being inside the limits of the physical space and how it's actually made.
Wow.
It's like some kind of multi-dimensional puzzle where every single piece has a knock-on effect on every other piece.
Okay, that's a lot for even the smartest human
Oh, yeah.
to deal with. So how do they even start? How do you teach an AI to do this? It's not like you can just hand it a textbook on chip design.
Right. And this is where deep reinforcement learning comes in. Think of it like this. Remember how AI mastered the game of Go? Researchers didn't program every single move. They made a system where the AI learned by playing tons of games against itself. Every time it made a good move, it was rewarded. Every time it made a bad move, it was penalized.
Okay, so they basically built a virtual playground for this AI to learn how to design chips.
Yeah, exactly. They created this simulated environment where the AI could just mess around with different chip placements.
Okay.
Every time it found a placement that made the chip better, things like processing speed, we call that PPA, by the way,
Okay.
power consumption, overall size, it got a virtual treat. Like we're training a dog here. And over time, the AI learned which placements worked best, even coming up with stuff that human engineers hadn't thought of before.
Wow, so it's actually learning and improving all on its own. But did this virtual training actually work in the real world? Can this AI actually go up against a real human chip designer?
Yeah, that is the million-dollar question. The results are actually super interesting. So they put this AI up against not just the standard design software, but actual experienced human chip design teams.
Okay.
And get this, in a lot of cases, the AI was right there with them, or even did better than the human design chips in terms of
Wow.
performance.
Surpassing human experts. That's a bold claim. Do they give any specific examples of what the AI was doing differently?
So there's this great example they point to. They call it the donut chip. Basically, the AI started putting certain components in these circular, like donut-looking structures.
Really?
Something that human designers just hadn't really messed with before.
Donut-shaped clusters of components. That's wild. What's the advantage of that? Why a donut?
Well, it comes down to efficiency.
Ah.
These donut arrangements, they actually made the wires shorter. Remember those data highways we talked about?
Right, shorter wires means
Exactly.
faster data and less power used.
Right. Shorter wires equal faster data transfer and lower power consumption. It's a small tweak with a big impact on how well the whole chip performs.
So the AI wasn't just copying what it had seen before, it was actually coming up with completely new ways to make these designs better.
Exactly. And that's what makes this research so cool, is like this AI could push chip design further than we thought was possible and lead to even faster, more efficient, more powerful technology.
Okay, this is seriously cool stuff, but
Yeah.
it also makes you wonder, what does this mean for all the human chip designers out there?
Sure.
Are we going to see AI take over this whole thing, making human engineers obsolete?
Well, that's something people worry about. But
Right.
this research actually points to something more like a team effort.
Okay.
AI is great at optimization, going through tons of options.
Mm-hmm.
But human intuition and creativity, those are still super valuable for chip design.
So not a replacement, but like a new super tool for a designer to use.
Exactly. Imagine AI taking care of all that boring, time-consuming optimization stuff.
Yeah.
It frees up the human engineers to focus on the bigger picture,
Yeah.
the overall chip architecture,
Right.
the applications, and seeing future tech trends. It's like having an AI assistant to go through mountains of data and suggest solutions,
Right.
while the human designer is still the architect calling the shots.
I like that that's a future I can get behind.
Absolutely. And the best part, this isn't just about chip design. This whole human-AI partnership could totally revolutionize any field that has these complex design and optimization problems.
So you're talking about like everything from solar panels to medical devices to even, personalizing treatment plans based on someone's DNA.
Oh, yeah.
It just keeps going.
Yeah, it really makes you think about the big picture, doesn't it?
Mm.
If AI can revolutionize something as complex as chip design,
Oh, yeah.
imagine what it could do for healthcare energy.
Right.
Even things like personalized education or
Yeah.
predicting, environmental changes. Absolutely. It's not even just about certain industries. It's like changing what work even is.
Yeah.
We think about automation taking jobs, but what if it's more about humans doing more?
Giving us superpowers.
Yeah. Letting us tackle problems that we never could have on our own.
It's like that saying, right? AI won't replace jobs, but people who use AI will. It's all about keeping up and learning how to use these new tools to your advantage.
Exactly. This research isn't just, hey, faster chips. It's a peek into a future where it's humans and AI working together, pushing things further than we ever thought possible.
So where do we go from here? What does this mean for, me or anyone listening who's trying to keep up with all this crazy technology stuff?
The big thing is to be ready to adapt and keep learning. Be curious, Don't be scared of new tech, and be open to seeing how different fields can connect. That's where all the cool stuff happens.
That's a great point. The people who are willing to learn and change with the times, those are the people who are going to shape the future.
For sure. And who knows, maybe someday we won't just be using AI-designed chips. We'll be working with AI to design the next big thing.
Now that's a future I'm excited about. This has been a really insightful deep dive. Thanks for joining us and sharing your expertise.
Happy to be here. Always love talking about the future of AI.